So this is number 9. It says the problem looks at the electron geometry and hybridization of methane, CH4. And A says draw methane in its proper electron geometry. Well, methane is going to be tetrahedral. So it's going to look like this. So that's A. And I just sort of skipped the part where I did the Best-Lewis structure, but the Best-Lewis structure does have carbon single bonded to each of the hydrogens. That means there are 4 electron groups, and its electron geometry is tetrahedral. Now, if the electron geometry is tetrahedral, I can do a little better job of that there, color that in a little better. Then the hybridization is going to be sp3. And then it says justify this hybridization by drawing all the electrons in the unhybridized carbon atom. That's going to be the unhybridized carbon atom right here. And by unhybridized carbon atom, I just mean regular electron configuration. And we've done that now for a couple weeks. And then it says drawing and naming all of the energy levels for the hybridized carbon and then filling in all the electrons. So here's our energy arrow that we've seen so many times before. You go from low to high energy. That's not at all surprising to see that 1s then goes to higher energy to get to 2s and then 2p. And if you do the electron configuration for carbon, it would be 1s2. So it's 1s2, 2s2, 2p2. And carbon has 4 valence electrons, but let me put them in here. So 1, 2, up and down arrow, down arrow, and up arrow, where you can draw them inside the box. I drew them a little sticking out. So that's just regular electron configuration carbon from 2 chapters ago. Now, what I'm about to do, with nothing up my sleeve, is now hybridize carbon. And I already know, by the way, what the hybridization is. And if the hybridization is sp3, that means you circle the s and 3 of the p orbitals. And what hybridization does is it averages or mathematically recombines the orbitals. So averages, so hybridization averages the orbitals, at least as far as energy is concerned. And so I have 3 up here. I have 1 down here. If I were to bring them together, it might be somewhat closer to the p's. And all 4 of them would have the same energy. So sp3 colon 4 with the same energy. And I've circled 4 boxes, 4 orbitals, so I will have 4 orbitals in the hybridized carbon. I've also circled 4 electrons, and so I have to draw 4 electrons, 1 in each orbital. And what we would consider is that with carbon having been hybridized and having 4 equivalent orbitals, whereas it used to have different orbitals, but having 4 equivalent orbitals with 1 electron each, it's now ready to bond. And if we were to draw an orbital overlap diagram for methane, it would have carbon with 4 sp3 hybridized orbitals. And 4 hydrogens with its 1s orbitals. And 1s orbitals, just to check in about this, are spherically shaped. That's why I'm drawing it with the H in the middle. And each bond forms from 1 electron from each of them. And this is glorious. You see these little red dots right here that I'm drawing? Each of them, so at each sp3 has 1 electron from carbon. Here those electrons are. Anyway, so again, this is an attempt to visualize what we mean by the bonding. And I'm happy to answer any questions. But this orbital overlap diagram is not part of your answer for this. I just wanted to tie it into what we were doing here. This is your answer for this problem.